All right, seen a few more connections, so I'm glad we held off for a moment. Thank you all for attending today. Today's webinar, today's presentation is about optimizing your existing models. And we're going to talk through various approaches to improve the performance of your planning analytics environment. So just to kind of preface that a little bit, the definition of performance, most of what I'm going to talk about during this is going to be ways to improve your system, ways to do technical performance. But we are going to talk a little bit about user experience and things to take into consideration. The other thing that I want to note is the phrase planning analytics. So I'm going to purposely flip back and forth between the words TM1 and planning analytics. A lot of you know this as TM1. You've been doing this for a long, long time. A lot of you know this as planning analytics, basically the newer marketed version, the newer branded version of this. So most of this is going to be synonymous back and forth, but you're going to see a few screenshots and a few exceptions where we're going to specifically talk about one tool or the other. So with that being said, we'll get started. My name is Lee Lazarow, and I'm the Planning Analytics Practice Leader at Revelwood. I have been doing this for a long time, close to 2 decades, and I am certified in all aspects of planning analytics and TM1. Everything from user to developer to administrator. And based on that, we're going to talk through some of the aspects associated with things that I've seen, things that I notice in regards to how, what I've seen at clients and how we can, you can offer some optimization aspects. Okay. So from the agenda, we'll talk a little bit about who we am, why you would want to listen to us. But then in regards to the pieces that we're going to talk about is we're going to break it down into really the 3 biggies. Talk about cubes and dimensions. What kinds of things can we do associated with each one of those aspects? Talk about the 2 different levels of calculations. How we can have our live calculations, our rules, and how we can optimize that, and how we can offer some thoughts in regards to your on-demand scripts, your processes. And then we'll also talk about some other things that you want to take into consideration. Okay. So before we start, let me tell you a little bit about Revelwood, about who we are. Like I said, we have been doing this for a long time. I've been doing this for almost 2 decades, and as an organization, we've been doing it for 25 years. We are an award-winning IBM Analytics Business Partner, and the awards flow through in regards to tools that we've built, approaches that we take, implementations that we've done. We've won various different iterations of awards from IBM. We have hundreds of successful implementations worldwide of different sizes, different geography. We have implementations that are 1 or 2 person shop where there's a PC sitting under someone's desk. We have implementations that are thousands of users across the entire globe. We have done this with a team of certified and experienced consultants who do both parts of the equation. We talk business, we talk technical. So if your goal is to talk debits and credits, we absolutely can talk business side with you. If your goal is to talk bits and bytes, we talk about the technical side. The ultimate goal is for us to merge the 2 of them together. And that's where planning analytics, that's where TM1 comes into play. Okay. Talking about some of the optimization, talking about some of the things that we can do. Let's start with your structure. Let's start by looking at the cubes and the dimensions. Okay. So the way I want to start this, though, is I want to start by talking about dimensions and getting a thought, getting an understanding of it, of the way that you create your cube. The dimension ordering is something that's very important. But there's 2 different reasons that you would do dimension ordering: presentation purposes and technical purposes. Presentation purposes. This is what the users see. This is what you're seeing in the picture above the water. This is really what the users experience. And oftentimes, this is going to follow your chart of account segmentation. So if you're working with an accounting tool, you're working with some kind of a package where your full GL segmentation is company-department-account, then your dimensions are probably going to try to follow something similar because you want your users to think of their segmentation in the same way. And that's where the dimension order was possibly created. Okay? But there's a reason and there's a methodology in regards to the dimension order because it does come down to the technical side. It impacts your speed, it impacts your performance. More importantly, it impacts your RAM usage. The approach of how to use a database behind the scenes comes into play from the dimension ordering. Okay? So before we talk too much into dimension ordering, let's talk about what kinds of dimensions are out there. And all of your dimensions are really broken down into one of two classifications: sparse dimension or dense dimension. Okay? So what does that mean? If one element in the dimension has a value, then what is the probability that the other elements in the same dimension also have values, keeping all other dimension elements constant? But that's long. Let's bring that down to layman's terms. Really what that means is all other things being equal. If I have something associated with one element in this dimension, can I assume anything associated with other elements in the dimension? Okay. So the two bullet points here. So the first bullet point. If there's data in January, and I'm only thinking of January, I'm only thinking of time. So I'm not taking into consideration scenario and company and account and all those other things, all those being equal. If there's data in 1 month, what's the probability that there's going to be data in the second month? Well, if there's data in January, there's a good chance that there's also going to be data in February. And there's a good chance there's going to be data in March and April and May and all those pieces. Now, yeah, there may be some exceptions associated with it because right now you're in June and there's a good chance that you haven't closed any of your books or even loaded any data associated with June. So therefore you have 5 months of data for 2020 and you don't have data for the 7 months. But by the end of the year, you have to assume that if there's data in January, you're probably going to have data in February, March, all the way through December. That's what we call dense. That's the image up at the top right, where within that one bucket, you've got a lot of things that's packed in pretty tight. Now, on the exact opposite, doing a full 180, now we think of our account dimension. If there's data in account 601, then can we assume that there's definitely going to be data in 602? And the answer is no. The way that you use your account structure, the way that you look at it in regards to what accounts am I going to use, the business logic associated with that doesn't require that if I'm using one account, I'm probably using all my accounts. That's what we call sparse. Most of your aspects of your chart of accounts structure come into play here. Your company, your department, your cost center, your product lines, your SKUs, possibly if you go down that deep, your accounts. Most of those aspects are going to be sparse. When you think about your standard cube, time, in most cases, is going to be dense. And most of your other things are probably going to be sparse. Okay. Why does that matter? Why do we care about the difference between sparse and dense? And this is where the optimization comes into play. The dimension ordering within a cube will determine how fast can I go out there and grab data? How much RAM do I need? How much processing do I need? And there's a standard rule that we follow. Smallest sparse to largest sparse, and the smallest dense to largest dense. And I like to abbreviate that. I'm more of a to-the-point person. So I like to just say smallest to largest sparse, smallest to largest dense. And that's the way you structure your cube. Now, nothing is black and white. Nothing is something where I'm going to say, this is always the rule, this is always the checklist. And you're going to hear me say that a lot during this presentation. Okay, why? In this particular example, things can change. When I first built my model, maybe I used it where I only loaded in a certain amount of products. And then over the course of time, I have a whole bunch of new products, some of which I use, some of which I don't. Maybe I've deprecated some of my products and I don't use them anymore. Maybe even something like time. When I first built my model, maybe I built it in 2019. So when I first built my model, I knew that I was going to have data through all of 2019. And at the end of 2019, it's pretty packed. But now it comes down to 2020. And when it's time for me to build my new months, maybe I built 2020 and I said, I don't want to have to do this every year. Let me build right now 2020 and 21 and 22. And maybe I built a decade worth of time. Well, that approach where we previously said time is dense might have now become sparse because I'm planning, I'm doing things in advance. Dimensions can change over time, so use your judgment. Use your judgment to figure out what's sparse and what's dense. One exception to that rule, strings, text. By default, Planning Analytics and TM1 are numeric consolidation tools. So by default, it's designed to build equal sum formulas. However, the strength of TM1 is that I can put text, I can put words directly into the database. When you do things associated with text or when you do things associated with words, you do have to follow a little bit of a different process. And typically what that process is tell TM1 that there's some kind of word associated. In this particular example, when you create a dimension where you have text, that has to come last. So when you do your rule, smallest to largest sparse, then smallest to largest dense, and if applicable, then strings. Okay. So what happens if you created a dimension order within your cube and then determine, hey, that doesn't make sense anymore? TM1 and planning analytics give you the opportunity to optimize your system by reordering the dimensions. Now, when you do that, it's all done behind the scenes. It's done in memory. Okay? It doesn't impact any end user aspects. It doesn't impact your rules. It doesn't impact your processes, your Excel reports, your web templates, your PAW screens, pieces like that. Nothing will be impacted. So it's not something where you have to worry about. Reordering a dimension is a major endeavor. Reordering your dimensions gives you the ability to optimize your behind-the-scenes database. For those of you familiar with relational tools, it's the equivalent of indexing your SQL database. And the way that you do that is you simply just right-click and you reorder your dimensions. So over to the right, I have two screenshots. The top screenshot is what it looks like in the, I'm going to call it the old environment using Perspectives or Architect. The bottom is what it looks like using the new Planning Analytics within the PAW environment. And what you're going to see is each of those have three columns in it. Here's the original order of the dimensions that I created. Here's the current order, because I may have changed it since it was originally created. And that third column is where you reorder the dimensions. This is where you can determine that new order. And the way you determine a new order is you simply click on a dimension and you use the arrows up and down to move it. And once you've done that, you then have the ability to click on a button to check it. On the old world, it's the word test. On the new world, it's the OK, the apply. And what it will tell you is it will tell you what that percent change is. What our ultimate goal is to reduce the amount of RAM. So we want to see a negative number. And what we want to do is we want to see a large negative number. So it sounds kind of weird when I say it, but our ultimate goal is to have the largest negative number. If I had a cube that was using 100 meg of RAM and I bring it down to 90 meg, I've improved it by 10%. In that particular example, I would see my percent change is minus 10%. I don't necessarily know what the order is going to be. And this is why you have the ability to play with it a little bit. This is where you use your judgment. This is where you do some tests. Now, Perspectives has an option you can see up on the top of the screen to let your system help. So instead of you doing trial and error by following the rule, maybe you let the system make a first pass of it. PAW doesn't yet have that, but it is on the IBM roadmap, and it gives you the ability to do a bunch of playing, to do a bunch of testing. Lower the amount of RAM, makes your cube tighter, makes TM1 be able to process it quicker, optimize the overall usage of it. But when you're looking at the dimensions, it's not just about the order. It's also about the complexity. How many dimensions do you have? Are there too many of them? What you want to do is, this is where you walk that fine line. You want to walk that fine line of using enough dimensions to define the data, but you don't want so many dimensions that it makes it hard for the user experience. Okay? This is where you remember the tool is a consolidation tool. The tool is designed to be something where we can slice and dice, not necessarily the same as your relational, where I just add fields and fields and fields. Okay? It'll work that way, but it's not necessarily designed that way, and that's where you walk that fine line. You want to make sure that you have enough dimensions to give you the results you want, but you don't want to make it too hard for VBR formulas or TI commands or slicing and dicing. So the way you can think about it is, could some of your cubes be two cubes? What we often do is we'll create two cubes. We'll create a summary cube and then a separate cube, which is our detailed reporting cube. The summary cube could be used to do a lot of your reporting. This is where I'm going to see the balance of an account. This is where I'm going to see totals. This is where I'm going to see something that comes out of my financial statements. And then I'll create a second cube. And that second cube is going to have more dimensions in it. It's going to have some of our pieces that get sliced and diced a little bit more, and I'll be able to create drills and links and other kinds of aspects to link the two. And what I could also do is I could also use one of the new planning analytics features of hierarchies. The virtual dimension, the attribute-based hierarchy. There's a lot of different phrases I've heard about it, but this approach of being able to create those virtual dimensions is also something that could come into play in regards to not making it too complex. Remember, the ultimate goal is not only to make your computer work better, but to make the humans using it work better. And the more you put out there, the greater it is, because I've been to some clients who have 15, 16, 17 different dimensions. They've taken two completely independent sets of data and tried to merge it all together. And the cool thing about it is they could say, hey, I got a cube that stores everything. Well, the challenge that comes into play is from an end user standpoint, from the reporting standpoint, the end users say, I don't even know what some of this stuff means. This is where you think through the complexity. This is where you think, do I have too many dimensions? And even within that, do I have too many elements? And as you're talking about the elements, think about the naming convention. Are the names confusing? Do you have different elements that look alike, but maybe they have dots, maybe they have underscores, maybe they have anything that's hard to see? When you look at it, do you have one element that's called US and another element called US1? Or do you have US and U.S. something like that? When you're looking at it on your screen right now, and I've got it on a real big PowerPoint, it's real easy to see the difference between US and US underscore. But when you get into your TM1 environment and you're potentially looking at it on your laptop, and if you're anything like me, and as you're getting older, your eyes are getting worse, it might be hard, if even possible, to see the difference between US and US underscore. Also, what do they mean? Think through, are these names not just confusing and hard to see, but will your users understand it? There's a great blog that my coworker Brian Combs wrote in Revelwood's Knowledge Center called Names Really Can Hurt. And it shows some real life examples of people who created US versus US1, and at the time of development, they understand what they meant, but a year later they may have forgotten. Or I create something, Lee creates something as US and I know what it means, and I create US1 and I don't know what it means. But then my coworker Brian looks at it and says, I don't know the difference. Let me grab that. Remember, one of the strengths of planning analytics is single source of data. You want two people to generate a report and have the exact same numbers. If Johnny uses US and Sally uses US1, they might think they're getting the same numbers, but they're not. As soon as that comes into play, you have some data integrity challenges. People may not trust the system. Are your names confusing? And while we're thinking of names, let's also think about the cube names. Okay, a lot of different things that come into play for the naming, but from an optimization standpoint, the thing that I wanted to talk through is regular cubes versus control cubes. Okay, so control cubes. Control cubes were originally designed by TM1 to have behind the scenes stuff. Stuff meaning security and attributes and statistics and various things that end users don't want to see. And as a result, there's a whole bunch of hidden cubes, and all of these cubes start with a curly brace. For those of you who know me, you know I often call it the squiggle cubes. Those squiggle cubes are truly called control cubes. And like I said, they were originally designed by the tool to have behind the scenes pieces. But as people started implementing, as people started putting in new models and determined, I don't want people to see this control cube, I don't want people to see my global parameters, they created their own control cubes. And on a side note, control cubes can't be created using a normal aspect. The control cubes have to be created using a TurboIntegrator process. I was actually just reading something even this morning on the IBM blog that was out there, and people were asking about that. So just to let everybody know that you can't just create a control cube using a normal cube. There is a special way to create it. Okay? But the question is, how do you want your cubes to be named? Do you want your users to see it without having to specifically search for it or turn it on? In perspectives, the approach to turn it on and off, you go to the view command, you go into display control objects, and it's as simple as that. All your squiggle cubes will appear. In packs, similar concept. You go into your settings, and there's an option, a checkbox to turn on or off control objects. PAW does it a little bit differently. PAW will have two separate sections in it. So when you're in perspectives, if I turn on my control objects and I'm looking at my cubes, I'm going to get one giant list of cubes. I'm going to have all my squiggle cubes, my control cubes, and then I'm going to have all what I'm going to call the regular cubes, all together, just alphabetically sorted. PAW makes it even more exaggerated, where there's going to be a section for your regular aspects, your cubes, your dimensions, etc., and a separate section where it's going to store your control objects. This offers some ease of use for your end users. So if you don't want them to see something, it absolutely separates into a different section. Okay. Another thing to think about on optimizing are the subsets within your dimensions. So there's two different types of subsets. So approach number one is what we call a static subset. Define once, manually reset. Okay, so even though we say define once, really what it means is I'm going to physically define it. And then when it's time for me to change it, I'm going to do something. I'm going to manually change the subset and resave it. I'm going to run a TurboIntegrator script. I'm going to have some kind of chore that does it for me. But either way, it's some kind of a hard-coded, some kind of a lockdown list. And this is great for items that are not going to change. For example, time. Now, I have an example up there. I did a screenshot of a different time period you could see, but the concept is still the same, where if I want to look at the base level months are not going to change. If we get a new Roman Empire and he adds something in between July and August, like Julius and Augustus did, then maybe our calendar is going to change, but that's pretty improbable. It's not likely that our calendar is going to change. Therefore, your time subset is something that doesn't change regularly. But the other type of subset is what we call the dynamic one. That's going to use MDX. That's going to use an approach where it's going to refresh the list every time the subset's referenced. This is going to come into play for all that sparse components that we talked about before. When you load your data, there's a good chance that every month, maybe even every week, you're going to have brand new accounts. You're going to have brand new products. Maybe you have new companies and new departments, a little less likely, but it's very realistic that on the account and product side, you're going to have a brand new list. Dynamic subsets are great for that in regards to the fact that every time I look at the subset, it's going to recreate the list for me. And this is the kind of thing where we would want to use it more dynamic. And it's also a great opportunity to get started with MDX. So a lot of people have spoken to me recently and said, I keep hearing this acronym MDX, what is it? Well, what MDX is it stands for multidimensional expressions. It's the equivalent of writing a SQL query against a multidimensional database. And what we use it for is we use it to create subsets, create views. So for purposes of this exercise, we're going to talk about it as creating a subset. I want to be able to use some kind of an expression, run the expression, and have it give me a list every time. Okay? So dynamic subsets are a great opportunity to get started with MDX. If you're in Server Explorer, you can turn on a screen that shows you the MDX as you're clicking on buttons. If you're in PAW, there are some new things in the subset editor that will actually show you the MDX that you're using. It's a great tool. It's a great thing to get started with. Now, while we're talking about MDX, one side note to think about, and for those of you who haven't seen a bulletin, please absolutely contact Revelwood and get on our mailing list for some of these. We just released a bulletin a few days ago in regards to version 2.0.9. PAW 209 and 209.1 have changed some of the interactions that they have between MDX and security. So the approach associated with Dynamics is still great. We still recommend it. I think it's an excellent tool. But depending on the version of Planning Analytics that you're looking at, there may be some considerations into how you utilize it. And like I said, if you haven't done so, absolutely check the Revelwood website or contact me and we can get you a little bit more information about that. Okay. So now that we've talked about structures, now let's think through some of the high-level optimization or some of the pieces that I see on a regular basis about optimizing your calculations. So let's start with your live calculations, your rules. Okay. Rules are broken down into 4 sections, so you can see up in the top right corner. The left side of your rule, when I say left side, I reference the equal sign. The left side of your rule is your area definition. Where do I want that rule to apply? Then after the equal sign, you've got your qualifier. When do I want it to happen? Do I want it to happen at base level, consolidated across the board? Formula. Your formula is your calculation itself, and then your terminator closes it out. Okay. So what are some of the things that I've seen at clients and within organizations associated with the area definition? The area definition, if we look at the example that I have circled, says this is where the rule is going to apply. So that example that's circled said this rule is going to apply in sales. If I wanted that rule to apply for the sales account for just my actuals, I can make it say sales, actual within the square brackets. If I wanted it to just be this year, I could say sales, actual, 2020. And all of those things are great because they specifically define which intersection, which cells do I want this rule to happen. Okay. But I'm not required to have something in the area definition. Sometimes I could just have an open bracket, a closed bracket. And what we often call those is we call those bracket rules. And bracket rules are kind of cool because what they do is they say apply to everything. And what it does is it analyzes all cells. But by analyzing all cells, it impacts all the cells. So bracket rules are great, but it depends on where you use it. It's great as a catch-all for the end of the rule. So if I want to create something, as many of you know, Order of operations comes into play on rules. So it'll go first line, second line, third line, figure out where my specific cell comes into play. Once I hit something, then I stop and I use that rule. But if I didn't hit anything, bracket rule is great for the end of the rule. However, I go to a lot of clients and I see bracket rules at the very beginning of the rule. By building a bracket at the very beginning, it says right here, it may slow down performance. And I was debating whether I write that as may slow down or will slow down, because it's very probable that that's going to impact your performance in a pretty hefty way. Because of the fact that bracket impacts every cell in your cube, by putting the bracket at the beginning, it's going to slow down your processing because that cell has to come into play every time. And usually when there's a bracket, it's also associated with an if statement. So sometimes you could say I have an element with an if statement as part of my rule. Sometimes you can just make it bracket with an if statement. Okay. If I had a rule, so that particular rule on this screen says plan equals n colon. If the account is 601, do something. In this case, something means just put the value 999. Otherwise, continue. That if statement slows things down. Whenever possible, if you know the result of that if is going to be a single value or some kind of a group of values, put it on the left side. It's better to put the component inside the definition. Instead of saying left side, A equals if, comma, whatever, B, just make it A, comma, B on the left. Instead of saying if the account is 601, say plan, comma, 601 equals. Sometimes this comes into play. You write an if statement if it's in some kind of ancestry, or if it's in sentence, or depending on how you write the rule, where looking at the attribute, looking at the hierarchy, things like that. Those you're going to need if statements. But if you're looking at something where it's an equal sign or a not equal sign or something to that extent, there's a good chance that you could put it on the left side, which gives you better performance. And as a reminder again of what we talked about earlier is remember the order of operations within the rule. First come, first serve. Okay. Next section, qualifier. Okay. Qualifier is where you define when does this rule apply. And there's really three qualifiers, although I could say there's a fourth. Okay. Three qualifiers. N colon only happen at the base level. C colon only happen at the consolidated. S colon, this comes back to what we were talking about before when you use strings, when you use any form of text, you have to tell it specifically. And those are the three kinds. And I said, yeah, I guess you could say four kinds because you can also write it without a qualifier itself. By not putting a qualifier is the equivalent of saying use every possible combination. And that's where you want to think through what the qualifier is. Okay. The N is only for the base level values, but the blank is for everything. Do you truly want this to apply one level or not? I've gone into a lot of health checks, even some recent health checks where I've seen rules where it simply just says sales equals units times price. So what that means is that rule is happening everywhere, base level and consolidated. TM1 is a consolidation tool. So what it's designed to do, it's designed to say, let me calculate sales at January, let me calculate sales at February, let me calculate it at March. Now what I'm going to do is take the results of those three and roll up the results and make that happen for quarter one. It does it really fast. That's my technical term, really fast. But it does it based on the engine that it has behind the scenes. If I were to take away that engine and say, don't do the consolidation, instead just go to quarter one and do the same formula, it's going to slow things down a little bit. Let the system consolidate when you can, and that's where you put in the N colon. But the thing you think about, again, nothing's black and white. There's always some human intervention to come into play. Do you want that rule to be calculated at the consolidated level? Because sometimes the answer is yes. When you're doing some kind of a total, a percentage of total, a ratio, some kind of a calculation off the side, maybe I've got a list of all my expenses and I want to figure out what is this account as a percentage of total operating expenses. Well, we want that to happen at the base level, but we also want to do the calculation where it happens at total compensation. If I had one account where it's 2%, another one 3%, another one 4%, and then I have total comp, well, I don't want to add 2, 3, and 4 together. The total comp does not become 9%. The total comp is still a new calculation where I add the values and roll it up. In essence, a weighted average. In those particular situations, it makes sense to not have a qualifier. But almost every other situation, it makes sense to put the qualifier. Why does it matter? Optimization. The system is designed to do certain things. It's designed to be consolidation. It's designed to figure out some of the calculations. Utilize the system for its strength. By taking away that n colon when it should be there, will slow down your system. The formula. The formula now is where you're going to actually do the full calculation. Okay, and there's a lot of different things we can look at for writing efficient formulas and calculations, and a lot of things that we can analyze and look for. But here are 3 things that have popped out to me that happen a lot. Okay, thing number 1: nested if versus continue. Okay, so most of you know what a nested if is. If it turns out that you're writing something in Excel, you do an if and you do your true, and then you do a comma, and then maybe you do another if, or maybe within the false you do another if, and you've got a series of commas. Really what it is if something, then if something else, then if something else. Well, there are 2 ways you can write that. Approach number 1 is to write it as a nested if. Approach number 2 is to use a statement called continue. The continued statement will be faster. So if I have the ability to create some kind of a piece where I look at the beginning and then I go to the inside and I want to look at that, looking at the beginning with if whatever, comma, true, comma, continue, and then I create another if right below it where I have the next value, that's going to go faster. Okay. From a computer standpoint, it's always great to do that. It's faster, it's going to work well. But keep the human aspect in mind. Don't overdo it. It will become hard to read. If you're writing if statements that have 2 parts or 3 parts or something like that, where I guess maybe a rule of thumb could say if it fits on your screen, continue statements are great. But I've seen some clients where they have 8, 10, even 12 part if statements. And the fact that they're doing continue and continue page over page over page became hard, maybe even borderlining on impossible for a human to read. So think it through. This is where you walk through that balance of saying, what's more important? Do I want the computer to perform at its best, or do I want humans to be able to read it? The answer is always something in between. Another thing that I see a lot, inside rules, there are 2 different ways to pull an attribute. Approach number 1, I can use one of the ATTR functions, ATTRS, ATTRN, things like that. Or I can create a DB function associated with one of those control cubes that we talked about before. One of those control cubes is called squiggle element attributes underscore. And every one of the dimensions will have a cube called squiggle element attributes underscore dimension name. By doing a DB pull instead of the ATTR pull will make your system go faster. So whenever possible, try to do that as a DB pull. Now, for those of you who've been using TM1 for a while, and this is where I purposely said TM1, not synonymously, is for those of you who've been using TM1 for a while, you're familiar with perspectives. And this also comes into play on the perspective side. Perspectives, when you're doing your DBRW formulas and aspects like that, DBRW will work much smoother than an ATTR formula. So one of the recommendations we make is use your DB formula in perspectives instead of using any type of ATTR. PAX doesn't necessarily have that. PAX will pull DBR and DBRW and ATTRS all as the same speed, same performance. But if you're in perspectives, in addition to rules are always perspectives, or Excel is sometimes based on your perspective. Use the DB formula instead of the ATTR formula. And a third thing that we could potentially do is when you're looking at something, when you're pulling a specific element. So when I say a value versus a DB reference value, I'm referring to an element name, an element value. When you have the choice of pulling an element value as opposed to a DB reference, use the value. Okay. So in the example that I have below there, it says result equals n:601. So 601 is a specific element. And yes, if there's a couple of dimensions that have an element called 601, you may have to write it a little bit different. But really what I'm doing is I'm saying the element called result is going to get populated at the n level, only at the base level, for whatever's in 601. That's going to be faster than saying result equals n:db, cube name, comma, dimension 1, comma, dimension 2, etc. Because even though they're the same thing, and even though on the right, I've got a whole bunch of exclamation points or a whole bunch of those bangs, the one on the left, I'm looking at one dimension. The one on the right, I have to reference and look up every one of those dimensions. I have to associate those and take a little bit of processing time. The more compact, the shorter you can write your rule, the better it's going to perform. And now we get to the big thing. Now we get to the meat and potatoes, the greatest thing about TM1 and planning analytics. My opinion, always has been, always will be. Feeders are the reason that planning analytics is the fastest engine out there and will continue to be the fastest engine out there. So for those of you who know, the concept behind it, really what feeders are is, I like to think of rules as, how do I do a calculation? I like to think of feeders as, when do I do a calculation? And this right here makes the determination of how do I make it go faster. So a good example of feeders that comes into play is, if I was doing a simple calculation, my total revenue equals my units times price. If I was creating an Excel spreadsheet where I had a row with my units sold, I had a row with my price, and then I had a row with total revenue, I would build an Excel formula on that third row or on that bottom row that simply just says, take my value up for units, take my value for price, X times Y, there's my value. And now I want to do it for the year. So I'm going to create 12 columns, January, February, March, through the 12 months. And what I'm going to do is I'm going to copy that formula that I created in January and paste it 11 more times. And every time I process my spreadsheet, it's going to calculate this for me 12 times. Pretty cool. I get 12 numbers. However, what if right now I'm in June 2020? I haven't even loaded my June numbers yet. I've only loaded 5 months of data. Well, I know that 5 of my months are going to have units, but 7 of my months, I don't have any data. The result's going to be 0. If I know the result is going to be 0, why waste the processing? Why waste the time of doing that calculation? That's where feeders come in. Feeders are the when. This is where I tell the system, don't waste your time with the extra resources. So you could say to me, oh, that's stupidly, so what? Computers are fast. If I do 5 months or 7 months, I say, what's the difference? But now we say, let's take a look at this across the time dimension and across your products and across your accounts and I can go on and on forever. The example that I gave was 5 across 12. Well, what if that became 5,000 across 12 million or 12 billion possible intersections? That's where feeders come into play. And this is why I sometimes hear people talk about, oh, I wish I didn't have to write feeders. Oh, feeders are so complicated. Oh, I wish TM1 got rid of feeders completely. Feeders are the reason why TM1 and planning analytics have been, and in my opinion, will continue to be the fastest engine on the market, because it's your way of optimizing your system by saying, don't waste the time doing some kind of calculation that you don't need to do. Okay? The way it does it is it does it with this fancy name thing called the Sparse consolidation algorithm. But really what that is it's just saying, don't check every cell, only check the cell when you tell me to do it. And the way that you do it, the way that you turn that on, is you simply just put skip check at the very top, the very first line. Now, as always, there's an exception to the rule. Okay, if you're doing text, I've said it a few times that you may have to go back and do things a little differently if you're using strings. If you're using strings, your very first line says feed strings, but otherwise, your very first line would be skip check. Okay, there's a lot of different documents, a lot of different questions I can answer, a lot of different things about how can I make feeders more efficient. And I'm not going to go into that just based on time considerations for right now. But one of the things that I do want to point out is on feeders, how do we maintain the feeders? And one thing that I see a lot is from a maintenance standpoint. Maybe I'm building a system right now where I only want the calculation to happen this year because I'm doing a forecast. And then at the end of the year, I know that I'm already starting to work on a 24-month budget. So my planning years are 2020, 2021, 2022. And I go to a lot of systems where I see I'm going to write my feeder and I'm going to hard code 20, 21, and 22. And I'm going to do it for Cube A and Cube B and Cube C, and I'm going to do it through my entire model. And then we get to the end of this year, and I say, okay, cool, 2020 is done. Now, I don't necessarily need to do 2020 calculations and feeders anymore. Next year, I want it to be 21, 22, and 23. Instead of having to be a developer, instead of having to go back and change all of my individual rules and all of my individual codes, one of the recommendations that we make is create a consolidation value that's going to be used solely for feeder purposes. And what we have the ability to do is write a feeder that would reference that consolidated element. And then in order to maintain the feeder, all we do is maintain the hierarchy. So in this particular example, right now, I could write a feeder that says, use planning years, whether it's on the left side or the right side of the feeder. I could say, reference that element called planning years, and then the system will be smart enough to know that means 2020, 21, and 22. And next year, instead of having to go back and change a bunch of cubes and a bunch of code and a bunch of feeders, I can instead just update one single hierarchy where I could change planning years to be 21, 2, and 3. And just by updating that one gives me the ability to now have all of my feeders come into play. I may have to reprocess it, and I may stop and start my server, or run a script to do some reprocessing, but I don't have to go into every one of my rules. I don't have to go into every one of my feeders. I don't have to go into every time I reference time. I can instead just have planning years, which impacted everything. And there's also ways to check to see, have I done too much feeding? Because the cool thing about feeding is you want to make sure that the system calculates every time it needs. But again, as always, that's where you walk the fine line. You want the calculation to feed every time you need it, but you don't want to feed it too much. And that's where you can create what they call an overfeed cube. And what an overfeed cube is, it's really just a replica of your existing cube. So you can create a cube with the same dimensionality. And then what we do is we write a formula to say, let me see where things are fed. Okay? In that new cube, you create a rule with 2 lines. Line number 1, skip check, because you want to tell the system, only calculate when I need to check something. And then the second thing you're going to do, second line, is going to use that bracket rule that we talked about. We want to check every value. As always, like I said before, there's exceptions. This is the exception. You want to use bracket because it's your only line. So you could say it's an exception because I'm putting it as the first line. I can counter by saying it's not an exception because it's also the last line. It's your only line. So that line is going to say, for everything, go back and check out the data in your source cube. And then what we do is from that source cube, we create a feeder, and that feeder is going to go to the new cube. Okay. And again, from time permissions and considerations and things like that, I'm not going to go into too much details about how it works or why it works, but really what you care about is you care about the end result. Any cell that shows up in this new cube is what we call an overfeed. It means it didn't need to be fed, but it is. Because it's being fed, it's taking up RAM. Because it's being fed, your cube is bigger. Because it's being fed, your system is not performing as well as it could be. This is where you step back and turn off your computer brain and turn on your business or your analytical brain and say, let me think about what's going on there. Let me try to figure out what feeder did I create that maybe could be done a little bit different. Let me look at it. Maybe an element isn't used anymore. Maybe I'm feeding too many years. Maybe I forgot to update that dimension that I referenced in the previous slide. But this concept of an overfeed cube is a real quick way for you to look at something and determine, do I have too much feeders going on in the system? And the final thing that I want to think through is in regards to rules is when to use the rules. Really what a rule is in this particular case is rules only use the rule when the calculation is necessary. And typically what that means is that comes into play for future planning data. So within the future, that's when you want your calculations to happen. Most likely you don't need it for history. As always, there's some exceptions. Maybe you've got C-level calculations, the ratios, the other things that we were talking about before where maybe it's not the end trolling. Those kinds of things you may want to continuously have calculated. But does it make sense right now for me to calculate a budget for 2019 and 2018 and 2017 because I've probably locked it down? By having those locked down values, we don't need the rules anymore. We can replace those with some kind of a copy-paste approach, what we often call a snapshot. And there's a lot of different ways that we can do that. I could use TurboIntegrator to write some kind of script. I could use a tool. Revelwood has a tool called Data Manager. Maybe I even do something just off of an Excel spreadsheet. A lot of different approaches in regards to how I get that data back there. But the key takeaway from this slide is let's minimize the rules. Only use those rules for the future. In most cases, don't use them in the past because we're using extra processing. Now we shift over to the other kinds of calculations. TurboIntegrator processing, the on-demand scripts. Logging. Logging is probably one of your biggest things in regards to speed or slow down on how long does it take a TurboIntegrator process to run. Why? Because what a log is a log is saying for every one of my records, for every one of the data points that I'm doing, when I'm doing my cell puts or I'm doing my loads, let me write that out to disk. And for those of you who know computers and those of you who are pretty technical, you know the slowest thing that you can do with a computer is write to disk. Back, right now, yeah, it's fast. It's definitely faster than it was 20 or 30 years ago. For those of you old people like me who remember computers back in the 80s and maybe even the 70s, you remember hearing the noises when you wrote to a disk. You would hear the grinding, you would hear the spinning, but you knew that it was slow. You knew that it was taking something that was in memory and writing it somewhere and saving it somewhere. And even though it's faster in today's world, that rule still applies. One of the reasons that TM1, one of the reasons that Planning Analytics is one of the fastest engines on the market is because it does everything in RAM. It does everything through a memory method that it doesn't have to do input-output back to a disk. Logging is where we send it back to the disk. So whenever possible, turn it off. What does that mean, whenever possible? Well, it's not needed when you're loading data from some kind of a system that you can easily go back and look at. When you're grabbing data from your accounting system, if something happened and I need to go back and look at the records, I can always go back to the accounting system. If it's from some kind of a source file, I can always go back to that source file. When Johnny the planner puts a number in, you definitely want to keep a record of that, because Johnny the planner is thinking of it in his head. But when you're pulling it from your accounting system, you can always go back and reference it. So what we recommend is that you disable it. Disable it in the prologue, re-enable it in the epilogue using that command called CubeSet log changes. Now, it could be as simple as writing a line in the prologue that says, CubeSet log changes, let me set it to 0. And then in the epilogue, we turn it back on and we say CubeSet log changes and set it back to 1. Okay, but we definitely want to take other things into consideration. What if the process crashes in between? What if your data source has some kind of an issue? What if something goes wrong and your TM1 system completely goes down in the middle of a process? The Revelwood Knowledge Center has a series of blogs that we have out there of recommendations of how to turn it on, what are uses of it, what are mechanisms to take those things into consideration. So the takeaway from this is to turn off the logging, but in regards to how, I recommend that you check out the Revelwood Knowledge Center to see some approaches that we use on that how. We also want to think through some ways that we create those TurboIntegrator scripts. In the prologue, we recommend that you create the view instead of using a pre-saved view. I go into a lot of clients where I open up a process and the source of that process is go to the Finance Cube and look at some kind of a saved view. Sometimes that saved view may start with ZZ. Sometimes it may have some kind of a name. Sometimes people even save the view as do not change. But the reality, people change it. It's just human nature. If you tell me don't go in that door, there's a good chance that I'm going to go in the door just because I want to know what's going on. If you tell me do not change this view, there's a possibility that people are going to change the view. And if that happens, your TI process is going to have issues. What we recommend is recreate the view in the prologue and then use a command at the end of the prologue that tells the system, hey, use this newly created view. And that way you're never going to have the issues. You're never going to have the challenges associated with with that view not being there anymore. Another thing that we see, and this brings us back down to performance. Reuse your subsets when you can. Okay, so if I am creating something where I need to create a view in the prologue, I'm probably going to want to create that subset on the fly. Whether I use a dynamic subset, whether I do a static, whether I do some kind of an if statement or an MDX expression, a lot of different ways to do it. Okay, if you do it once, you do it. TI is really fast. But what about situations where I'm going to do it over and over and over again? In situations where maybe I'm going to create some kind of a while loop, or maybe I'm going to create some kind of a view where in the prologue I create the view, and then in the data source I have some kind of an if check, and if criteria meets, then maybe I run a part 2, or maybe I recreate the subset on the fly, or do something like that. I've gone to a few clients who have created processes like that, and what happens is in those processes, they often recreate the subset as part of the iteration. Well, if I had something where I'm looking at the months within a quarter, there's only 3 elements, and yeah, it's going to improve your performance a little bit, and it's going to help. But I have gone to clients where we are going to do some kind of a loop where maybe we're doing thousands of iterations on my wow, and then for each time I'm recreating a dimension, I'm recreating a subset in a dimension that has thousands and thousands of elements. Well, if I'm creating a subset using some kind of a while loop one time, yeah, it goes pretty quick. But if I'm doing that same exact thing thousands, or in this particular case, millions of times, it will absolutely impact the performance and the speed of your process. If you can reuse the subset in some way, do it. Okay. Also, The approach associated with temporary. Okay, depending on the version of Plan Analytics that you have, the subset create, the view create, give us the ability to create these values as temporary. Okay? Why does that matter? Because it helps you clean up your system. Many clients that I go to and many implementations that I do, we say, hey, we're going to pop this thing out there. We're going to do this one-off, or we're going to save this piece out. And the client will say to me, yeah, you know what? I'm going to go back. I'll clean it up every 3 months. I'll clean it up every 6 months. I'll make sure that it stays clean. Well, just like in your situation right now, a lot of people listening to this are working from home right now. The great thing about working from home is you're working from home. The bad thing is you're seeing your home now for things that you might not have paid attention before. You're walking up to your attic, you're going into your garage, you're even looking in your pantry, and you're saying, oh my gosh, I have had this stuff here for years and I never got around to cleaning it up. It's painful. Well, that same approach comes into play through your TM1 system. When you eventually have all these views, when you eventually have all these subsets, when you eventually have all these pieces that are floating around, it just makes it harder to navigate. It makes it harder for you and for your computer. Most situations when you're writing the code, you're going to create something in the prologue, you're going to delete it in the epilogue. But a lot of people, myself included, sometimes get lazy when you write the code. We'll create something in the prologue and we say, we'll get around to setting that delete. We'll get around to doing that destroy command in the epilogue, but we never do. Create something as a temporary, and you don't have to. Some other things to keep into consideration. When you're doing your code, use your variables. Whenever possible, use variables instead of hard coding values. For example, a cube. Maybe I'm referencing something across a finance cube. Well, I can write something and I can create a variable called strcube to reference finance. And then I can go over and over again through my prologue and my data and all the other tabs, and I can reference strcube. And then I say, you know what? I'm in the process of building a new cube, but I want to use this script again. Well, by having it as a variable, I only have to change it once. I don't have to continue to change it over and over and over again. Change once, use many. Kind of like what we were talking before on the subset. Okay. When you're creating those variables, what I recommend though, use some kind of useful name. Use some kind of a prefix or some kind of a naming convention that makes it easy for you to use. Me, personally, I like these 3 characters. GLB tells me that it's from the global value. It's going to be used across the board. STRNUM tells me whether it's a string or a number. Helps with my attributes and my cell gets and things like that. Maybe I have VAR because I know something's on the variable tab, PAR for the parameter. Either way, give it some kind of a useful name to ensure that you know what it is, you know how to use it later. Also recommend use comments. Okay? Using comments gives you the ability to make sure that you remember what's going on and other people know what's going on. By not using comments, I'll be candid when I say this, it's lazy coding. I like this quote. I've used this quote for a long, long time. Again, those who know me, you've probably heard me saying this over and over again. Any fool can write code that a computer can understand, but a good programmer writes code that humans can understand. Use it to describe your steps. Use it to reference other components. Use it to make sure that when you come back a year later, you know why you did something. It makes it easier for you to debug. If things go great and you get promoted or you move on to a different role or you move to another aspect of the company, there might be a new TM1 administrator there who's going to have questions. Putting those comments in there help them understand it, which is less hassle, less overhead for you. Okay? And depending on the version that you have, Paul also has a new feature in there called regions. Regions allow me to group things together, and it allows me to actually hide aspects that I don't want to read. I've gone into situations where I say I need to read some code, and I look at 1,000 lines of code, or just make it small, even 20 lines of code. Well, when I print out an entire rule, then I have to use a piece of paper to block things out, or I use something because I don't want to see too much. I just want to see the piece I'm focusing on. Regions will help you with that. Some other things to consider. Overall performance. There's a whole bunch of those squiggle cubes called StatsBy, and these are all performance monitoring cubes. These are the kinds of things where you can look at to figure out how big are my cubes, how much memory am I taking up, how are some of my processes doing. And server recycling. This gives us the ability to reset some memory. It gives you the ability to periodically, I'm going to say air quotes, fix your machine. If you've ever called IT support or even your cable box or something like that, one of the first things that they always say is they say, turn your machine off and turn it back on again. Reboot your cable box, reboot your computer, reboot your cell phone. Server recycling is the same exact aspect. It's in essence a reset button as a starting point, and it's something for you to think about. Okay. You also want to think about backup approaches. You want to think about different kinds of backups. IT is absolutely making a backup of your machine, but you want to think of different kinds of backups. A redundant backup. I just want to make a backup of my database periodically, and if something goes wrong, maybe I can fix it myself. I talked to a client this morning who accidentally deleted an element and said, I just want to go back to what I had yesterday. I don't want to get IT involved because they're so busy. That was one kind of backup. But we also talked more about the disaster recovery. How do we make sure that there's actually a full backup that we have? Okay. These are all the kinds of things to keep in mind. These are all the kinds of things to consider. So the purpose of this presentation, based on timing, I know we're hitting the end of the hour. We talked about a lot of topics. We specifically talked about high level of a lot of topics. If you have any concerns with your existing model, Revelwood offers a health check that we call our performance tune-up. And it gives us the ability to come in and look at all these aspects, figure out how your model is functioning. We're going to look at the things we talked about, your dimension order, your rules, your processes. We're going to look at some of the things that we just saw on the previous slide associated with backup mechanisms and naming conventions. We're going to look at your computer. We're going to look at your business processes. We're going to think through on your process optimization. It's a very important aspect that most people don't take into consideration. It's real easy for me to build a computer program and say, just click on A, B, and C. But if you step back and think about it, you really need C. We've gone into many, many situations where we see some kind of a script or some kind of a business process or some kind of a physical thing happening with a handoff where not all the pieces were actually needed. Some of them became repetitive. Revelwood offers that service where we can come in and we can offer some thoughts and assist you with that. But if you want to take some steps on your own, I referenced a few times the Revelwood Knowledge Center. On the Revelwood website, we have a section called How We Think, and within that, there's a Knowledge Center. There is additional detail on many of the topics that we talked about this week, and we continue to update it. We update this site every week. We create some kind of a posting. Sometimes that posting entails words. Sometimes that posting entails a video. Sometimes it's associated with a technical item. Sometimes it's associated with a process. Sometimes it's not even associated with plain analytics. The one out there right now that we just posted this week is associated with a cool new Excel formula that may help you out. But I definitely encourage you to recommend to check out the Revelwood Knowledge Center to learn a little bit more. But if you do want to talk a little bit more about anything, please don't hesitate to contact me. I thank everybody for your attendance today. I thank you all for joining me. Please don't hesitate to contact me if there's anything that I could answer further about any of your optimization questions. You can contact me at this phone number, at the email listed on the screen, or you can contact us directly through our website. Thank you again. I appreciate all your time today. Everybody stay safe, and we'll call it a day from here. Thank you.